Quiz 9 was on three-phase transformers. Let's go over it now. Number 1, how many degrees are the voltages in a three-phase transformer out of phase with each other? 120 degrees. Number 2, three-phase transformers are constructed by winding three separate transformers on the same core material. This is a true statement. And we're going to see examples of this further on in the quiz. When calculating three-phase transformer values, the rules for three-phase circuits must be followed, as well as the rules for transformers. This is also a true statement. For number 4, we need to write in the H1 and H2 terminals. The H terminals are on the primary side of a transformer, and the 1s are where the input voltage is connected. So we have H1 here, H1 here, and H1 here. And then the H2s are literally the other ends of the coils. So we have H2, H2, and H2. For question number 5, we're labeling the secondary side of the transformer. This one happens to be a delta connected secondary. And for the secondary, we use X's for our labels. And every coil gets an X1 and an X2. So for this coil here, we have X1, X2, X1, X2, X1, and X2. My apologies for those of you that had a go at trying to do this on an online type situation. Some of you were very clever on how to do this. So thank you for having a go at labeling this. It's hard to do in an email. For those of you that couldn't quite figure out how to do that, don't worry about it. I'll certainly give you credit. I just want you guys to have a go at these quizzes so you'll be prepared for the final. Question 6 is asking what type of transformer is shown in this figure. So let's take a look at what we have. On the top coils we have L1, L2, and L3. That's where the input voltage is tied. So that means the top 3 coils, that's the primary side of the transformer. And then on the bottom we see that the load is connected. The load is always connected to the secondary of a transformer. So on the bottom is the secondary. What kind of connections do we have? At the top we see, on the primary side, we see that these 3 points are tied together. And we learned that when we have that, that's a Y connection. So 3 points of the 3 coils are tied together, and then on the other sides of the 3 coils, our input voltages are tied. That's a Y connection. On the bottom, on the secondary, we see that one end of one coil is tied to one end of the next coil, and so on down the line. So they're kind of daisy chained together, so to speak. And we learned that type of connection is a delta. So the answer to number 6, it is C. It is a Y delta transformer. Number 7 has us writing in the H1 and H2 terminals. Every coil gets an H1 and an H2. The H1s, that's where our line input voltages are tied. The H2s are where the 3 coils are tied together. So H1, H2, H1, H2. So again, the H2s are all tied together, and the H1s is where the input voltage is connected. Number 8, we're looking at the secondary side of the transformer. Again, every one of these coils gets an X1 and an X2. We use X's on the secondary. So X1, X2, X1, X2, X1, X2. For number 9, we have a delta connection here, and we need to write in the voltage values. We're given one right here, this 240 volts. So from point to point is 240 volts. So that means from this point to this point, this phase voltage is also 240 volts. That's this voltage right here, 240 volts. And then from this point to this point, again, 240 volts. That's this voltage here, 240 volts. We see that this coil is tapped. So we got, oh, that's not a straight line, sorry. It's tapped, so we have a neutral. So we are dividing this coil in half. We know that we have 240 volts across the entire coil. So half of the coil, from this point to this point, which is this voltage right here, that's half of the 240. So this is, oops, 120 volts. Boy, I'm not writing very well at all. Try that again, 120 volts. Same thing, this voltage here, this is the other half of the, so to speak, split coil. This is also 120 volts. Sorry for my bad handwriting. This voltage here is a little tricky. If you refer to the homework, it'll give you some clues on how to do the math, but really we're looking at the voltage between this point here and the neutral. So it's the voltage across this coil and across this half of this coil. Those voltages are 120 degrees out of phase, so they do not simply add up. You must use the 1.732, and that gives 208 volts. And for number 10, we have a Y connection, and again, we need to enter in the voltages. We are given one voltage, that's this one here, this 120 volts. that voltage is between this point here and the neutral. So basically it's the voltage between these points here, and it's 120 volts. That means the voltage between this point and this point, which is here, is also 120 volts. The voltage between this point and this point, again, this point here, is 120 volts. Voltage number 3 is between this point and this point. We have 120 volts across here, we have 120 volts across here. However, those voltages are 120 degrees out of phase, so they do not simply add up. It's that whole 1.732 calculation again, like you saw in the homework, and that gives us 208 volts. Likewise, between this point and this point, which is this voltage here, 208 volts. And then the voltage between this point here and this point here, that's this voltage, 208 volts.